And now for our last exponent rule, rational exponents. Let's take a look at an example. This time, 32 to the power of 2/5. That's a positive exponent, so we know it must represent repeated multiplication. So let's try it. 32 times 32, right there would mean 32 to the power of 2. But that's not what our exponent is, so let's erase this one. So now we just have 32. That's 32 to the power of 1. 2/5 is less than 1, so let's keep going. Maybe that's 32 to the power of 1/2, but 2/5 is smaller than a half, so maybe that? Maybe? Clearly that's ridiculous. That's not how we deal with numbers. We don't just erase parts of them. Here's our rule of rational exponents. When we have a rational exponent, the denominator means something special. Just like in negative exponents, the negative sign meant something special. It didn't mean a negative number. In this case, the denominator doesn't mean we're dividing by something. Instead, that denominator means we're going to find the nth root of something. For example, if our exponent was to the power of 1/2, that would mean we're finding the square root of that number. Now, normally with square roots, we don't write the number 2 here, but we can if we'd like. Or it also means if I had b to the power of 1/3, it'd be like writing the cubic root of b. That denominator represents a root. Then you'll notice the numerator acts like it always has, as a regular old exponent. Let's see this in practice. Let's go back to that first example, 32 to the power of 2/5. And let's use the fact that that numerator and denominator represent different things. Let's start with the denominator of 5. That means we're going to find the 5th root of our base, 32. And our numerator of the exponent is a 2. That's going to just be a regular exponent like we've seen. So let's simplify this problem. What is the 5th root of 32? It is, in fact, the number 2. And we still have our outer exponent here. Now we have 2 to the power of 2. And if we expand that, it's 2 times 2, which we all know equals 4. So in the end, 32 to the power of 2/5 equals 4. Let's try one more example. Whoa, the square root of 25x to the power of 3. Now, we've seen problems in the past like the square root of 25, and we know how to do that. But what if we have x to the power of 3 in there too, and they're being multiplied? Let's take a look. Instead of dealing with this square root the same way you always have, let's use our new knowledge of exponents. That square root is the same as having that base, all this stuff, to the power of 1/2. That denominator in the exponent represents the root. In this case, a square root because it's of the number 2. Let's put our base back in there. And this is one way we can start dealing with it. Now, we have two numbers being multiplied, raised to a power. How do we deal with that? We can deal with that by looking at the exponents on both of the numbers in our base. The 25 has an exponent of 1, and the x has a power of 3. And we've seen that when we have a power raised to a power, all we need to do is multiply those exponents. So we get 25 to the power of 1 times 1/2, that would be 1/2. times our x to the power 3. Our x, the 3 and 1/2 multiply to equal 3 halves. Okay. We can actually simplify once more. Remember that this exponent represents a square root, and we know the square root of 25. So our final answer will end up being 5 times x to the power of 3 halves. And this is a way of writing this same number without roots.